well, let's find something that doesn't require any soldering. Should be easy. And we looked and we looked and we looked and we couldn't find anything. So I said to him, well, you're going to have to invent it. So he did. So he invented Xinabox. Okay. So here, for example, is a weather sensor in the middle here. So this little guy in the middle of the moat, it will give us temperature, pressure, relative humidity. And using that data, we can calculate cloud altitude and dew point. And then over here, we've got a nice little light sensors. So we can do ultraviolet and we can also do visible light. And all of the components are put onto these identical boards, and we use this connector. So every board is the same size. In fact, what we did for a bit of fun is these larger holes over here in the corners, they actually fit directly onto Lego. So, so what we did is we used the Lego standard, because Lego has got such a good standard. We thought, one never goes wrong with Lego. So here we go. Everything works better with a little bit of power. And then I've got a little screen over here. Put that in. And a little CPU, because we need to have a brain. We need to have a brain of sorts. So this guy over here has got a 4 megabyte memory, and it can run Arduino, Java, Python, MicroPython, and as you can see, it's got a Wi-Fi hub at the back. So so what I've done is I've put this together, and in fact, one can put it together in any format. It doesn't have to be like that. It can be put in any kind of format. It all runs exactly the same voltage. All runs I2C as a communication protocol. So what I need to do now is I need to add some power, because if I put it into my laptop, you're not going to be able to see it through the camera. So let me quickly find a power bank. Here we go. So there we go. It's powering up now.
Yes, I can see the little light.
It's telling me that it's address. It's looking for the Wi-Fi to connect to the Wi-Fi. What it'll do is it'll count down, and then it'll start displaying the data on the little screen, as well as on a data dashboard, a web-based dashboard. So so this is really just a starter kit, of what we call the weather station starter kits, and we call each one an X chip. So we've got over 80 different X chips in full production. So we have a GPS, we've got an accelerometer, a magnetometer, infrared sensor, gamma ray sensors, multitude of them. We've got different power solutions. So instead of using USB, you can have coin cell battery or solar power, AA battery. We've got different CPUs. We don't have to use this one with the Wi-Fi. We have Bluetooth. We have long-range radios. We have a global star chip, all of that kind of thing. So what we did is we started using these X chips. I don't think you can see it here, but the data is also starting to display on
we can see the display.
Yeah. So the thing is, what you can do is you can run around outside and indoor and compare the data and all of that kind of thing. And what we've done is we've done it in centigrade as well as Fahrenheit, so that we can engage everybody in the world. Not just imperial or metric. So in August 2016, my husband Bjarke, so our inventor, Bjarke Gottfredsen, he is Danish, so that also explains the Lego, so what he did is he went with the specific purpose of showing Xinabox to Professor Bob Twiggs.
More engineers are not going to solve your problem. It's not a technical problem in that sense. It's a process problem. And the time to fix your processes was 20 months ago. And the second best time is today. This is Jason Kanigan, the president of Cold Star Technologies and the host of this podcast, the Cold Star Project, which is all about identifying and solving process problems for space companies, because that's what we do. And you can hear the entirety of this episode by following the link in the comment below.